Hello everyone. Welcome to this exclusive Royal Cyber webinar on mastering real-time data ingestion with Databricks AutoLoader feature. We are glad to have you on board for this presentation. As data streaming and data streaming analytics are becoming more and more common in today's environment, corporations have various use cases for using data streaming and analytics to perform real time analysis of what is going on in their organizations and use that information to make tactical and strategic decisions. So, in this scenario, Autoloader is one of the Databricks features which is quite helpful and can be used to do streaming analytics in a short amount of time without actually developing any infrastructure or any code related to real-time data ingestion, which was done previously in case organizations needed to do any real-time data processing. So let's move on. So in this presentation, I am Zishan Arif, and with me is Rahil Fazil. I am the practice lead of the data analytics department for the data engineering practice. I am responsible for guiding the data engineering efforts in the organization at Royal Cyber. And with me is my colleague Rahil Fazil, who is a data engineer in my department. And we work together to develop the solution for this webinar. So this is the agenda of the presentation. First of all, we'll have an overview of the Royals of our organization, Royal Cyber. Then we'll discuss the Databricks Autoloader platform. What is Databricks and what is the Autoloader data platform in detail? Then we'll discuss the Autoloader implementation, how we implemented our solution using Autoloader, and we'll also discuss some of the configuration features of Autoloader. Finally, we'll also present to you and demonstrate a real-time autoloader case study in which we simulate stock prices in real time and calculate portfolio net present value in real time as the stock prices are being generated. Finally, we'll discuss the lessons learned in this project, and then we'll have a Q&A session. So, this is the overview of Royal Cyber. We are an IT consulting and digital transformations company specializing in services, solutions, and software. We have 20 plus years of experience in the industry, and we are located across the globe in multiple countries and in multiple locations. We have more than 2,000 employees globally and more than 250 certified consultants. We have 600 plus clients across the globe, and we are technology partners with all the major vendors, including Snowflake, Databricks, SAP, Microsoft, Salesforce, and AWS. And we have won various awards and recognitions as can be seen in this presentation. So this is the overview of the data analytics practice in which we offer the following data analytics solutions. First of all, we have the data engineering solutions vertical in which we help organizations and clients solve their data engineering related problems, in which we basically streamline and automate the business processes of our clients by turning the data from disparate sources into single databases, or what we call a single source of truth solutions. So our expertise include business process automation, data strategy, data security, data warehouse, data lakehouse and ETL solutions, business intelligence and reporting, and advanced analytics. Next, we have the machine learning solutions, in which we help our customers create custom machine learning solutions for advanced analysis, optimized prioritization, improved customer services across various industries. And in this vertical, our expertise include data pre-processing, feature engineering, model building, model selection, hyperparameter tuning, and creating endpoint for model serving. That is deployment. Then we have the generative AI solutions vertical, in which we help customers solve their business requirements for generative AI, such as chatbots and other generative AI related business process improvement solutions. So basically, we train generative AI solutions on massive data sets of text, images, code, and other media, and absorb patterns and relationships within that data. And we basically also provide solutions for multi-model generative AI solutions, in which we can our generative AI solutions can generate text, images, music, code, and more. Finally, we have the ML Ops solutions vertical. That is, we also build solutions for customers if they have some specific business needs or enhance their existing ML solutions. Depending on the requirements, our specialists recommend the best areas to create model into the service. So next we'll discuss what is Databricks and why are we using Databricks for this webinar and this case study and this solution which we are presenting. So as we all know, Databricks is a leading provider of unified data analytics and AI solutions, empowering organizations to harness the power of the data at scale. So Databricks is a cross cloud or across multiple clouds data lakehouse service, which uses the Delta Lake storage protocol to basically allow users to implement their data lakehouses in a scalable and on-demand fashion on the cloud. So Databricks enables seamless integration of data engineering, data science, and business intelligence on a single platform. That is, Databricks is one out of the box solution in which all different areas of data analytics, analysts, and resources can use the Databricks platform for their own business needs. For example, it doesn't require that a data science team has its own solution in which it has to pull some data out of the given data catalog and then process that data in a different environment and then present a data science solution, but rather all the data engineering, data science, and business intelligence and advanced analytics solutions are present in the same Databricks environment. And given the role-based security features of Databricks, we can securely share and access these data sets across different teams as and when needed. So this was an overview of the Databricks and why we are using Databricks for the solution. And of course, AutoLoader is a Databricks feature which is available only in Databricks at the moment. And it can be used, as I mentioned earlier, for automating and easily deploying data streaming analytic solutions for organizations which need to get an overview of their organization in real time. So in this slide, we'll discuss the Databricks Lakehouse architecture in general. So basically, Databricks data lakehouses are a unified data platform which combine the strengths of traditional data warehouses and data lakes into a single architecture. They provide a centralized repository for structured and unstructured data, enabling seamless integration and analysis. So in a Databricks data lakehouse platform, like generally speaking in data lakehouse environments, we have data warehousing, data engineering, data streaming, and data science and ML verticals. We basically utilize the Unity catalog of Databricks to access all the data artifacts like different tables and different data models and notebooks, etc. And those tables are built using the data tables, which are built using flat files of cloud or like images or audios which are present in the cloud object storage. Like in case of Azure, the cloud object storage will be the Azure Blob storage account. So following are the main benefits of the Databricks Data Lakehouse solution. It is a unified data storage area. It allows for schema enforcement and evolution. For example, let's say we have a table in our data lakehouse and we need to add a column to that data. So this can be done gracefully and without any downtime or without any issues. Databricks will handle the added column in the pipeline by itself. And also, since it basically stores data in the Delta Lake protocol, it allows for asset transactions, and that is the prime feature of all data warehousing solutions, that asset transaction guarantees are required. The data lakehouse is a scalable, cost-efficient solution and a cost-efficient solution, and it allows for data governance and security, and is also flexible and agile in terms of its. So now we'll discuss what is streaming analytics and why we are discussing streaming analytics in detail. Is because it is something which is highly in demand at the moment. As organizations are growing, they need real-time picture of what is going on in their environment, what decisions are being made. For example, a bank would need to know how much sales they have produced, how much sales they are producing, or what is the value of the current portfolio of stocks at any given point in time. And as organizations grow, the size of the data and the data volume also grows exponentially with it. So a scalable solution is required for allowing those organizations to use streaming data analytics. So, but what is streaming data analytics generally speaking? So, streaming data analytics enables organizations to perform real time analytics on streaming data. So, basically, it is a type of data analysis that processes data stream as they are being generated. So, in streaming analytics, what we need, the general traditional way of doing data analytics was through batch processing, in which an ETL process or a data pipeline would execute at a certain point in time on every day, and it would extract data from source systems in the form of batches like millions and billions of rows, and then process that data once a day, and then generate reports and BI business intelligence solutions for the management to view. But as you can see, the limitations of batch processing is that it is only with the picture of the whole organization is visible only once throughout the day. But as organizations grow, as their operations become 24/7 and round the globe, so streaming data analytics is becoming more and more in demand. And basically, as I mentioned, that it helps management and organization to see a real-time picture of their organization, and as that organization evolves throughout the days. So for streaming data analytics, of course, as the data in the organization is also growing exponentially, so we need a scalable solution which can help organizations scale their streaming analytics solutions as the data grows, so that this analytic solution doesn't fail or doesn't choke when the data volume or the data velocity increases. So that is where Databricks comes in, which is a scalable unified data analytics platform, and it enables organizations to do streaming analytics with minimal amount of effort and reliably and in a fail-safe manner. So, as I mentioned, so streaming analytics involves the use of continuous queries. That is, we need to query the source systems continuously and generate events and data streams to analyze data from sources and send data in small or micro batches and in a continuous flow as that data is generated. And finally, streaming analytics can perform simple to complex event processing calculations for delivering sophisticated use cases. As we'll see in this demonstration and case study as well in this webinar, that we are using autoloader and streaming data analytics to calculate a net present value of a given portfolio in real time. So let's now discuss the streaming analytics use cases and role in financial services. So in the financial services industry, real-time risk management, where market conditions can change in any instant, is not just a competitive advantage anymore, but it's a necessity. Real-time risk management is required for all the financial instruments which are exposed to market risk, and this is where streaming analytics comes in. That is, as the market prices of those financial instruments change, it should be reflected in the portfolios which contain those assets. And so the organizations can process and evaluate the portfolio risks in real time and at scale. With markets becoming more and more volatile and regulatory environments more and more complex, traditional methods of risk analysis, which involve batch processing, as I discussed earlier, are no longer sufficient. Finally, we need sophisticated technology capable of handling large scale data processing, that is, data at scale, and perform complex analytical computations on the data streams and seamlessly integrate with various data sources and systems in real time. And finally, what are the challenges being faced in the financial services industry for implementing those real time data analytics pipelines? Number one, given the high volume and velocity of data, as I discussed earlier, financial markets generate vast amounts of data and at extremely fast pace. So basically, processing that data in real time is a challenge because the data velocity is so high and the volume of data is so high that traditional data warehousing solutions just simply fail to scale. Financial instruments, as we all know, are complex and they basically have a diversity of sophisticated analytical models for risk assessment. So basically, if, different financial models, financial instruments like options and futures and derivatives, exotic financial instruments have different calculation requirements, and their values depend in sophisticated manners with the real-time financial asset prices. So calculating the value of those financial instruments in real time using sophisticated computations is a challenge, given the data volume and velocity of data. Regulatory compliance, as always, basically requires that we present frequent compliance reports to regulators if required in real time, and this is where a data streaming solution can help. And finally, market volatility and cybersecurity threats are also the areas where continuous monitoring is required, and a data streaming analytics solution can be used for continuous monitoring of the markets and for the systems for cybersecurity threats. And what are the challenges of the popular risk management tools available in the market? So basically, one of the challenges with real-time data processing is that it is particularly concerning in scenarios where instantaneous risk decisions are required as the systems struggle with real-time data processing. Finally, we have discussed most of the details in this slide already. So I'll discuss the last point, which is very important: handling high-speed data and system integration. So solutions known for their analytics and integrations capabilities might struggle in managing ultra high speed data streams, typically in high frequency trading scenarios. So as professionals working in the financial services industry would know very well that in high frequency trading scenarios, real time data analytics would become very relevant and very necessary for getting the real time portfolio values as the markets change and as the positions change in the portfolio. So basically, let's now discuss the requirements of streaming data of a streaming data analytics pipeline. So first of all, in as I discussed earlier as well, streaming analytics requires incremental data processing. That is, we need to process data only the data which is new and hasn't been processed before, and as it arrives in real time. So this requires incremental ingestion, which what we call incremental ingestion. That is only read new files. That is, we want to read only the data which is new and hasn't been processed already, as I discussed. Do not miss any file. That is, any file or any piece of data. We cannot miss any information in real time. That is, we have to process all the data in the data stream as and when it arrives. The pipeline should trigger immediately as and when the data arrives without any delays or as minimal a delay as possible, so that we have as near to real time picture of the portfolio as possible. Finally, the pattern in which we implement this incremental ingestion system has to be repeatable. That is, it must not require us to basically implement a new design pattern for this incremental ingestion pipeline as our portfolio requirements change, or as new files or different files are basically required or processed. That is, we need to have an incremental ingestion pattern which is applicable across different files, different financial instruments, and different use cases. Using the same pattern, we can implement incremental ingestion for implementing streaming data analytics solutions. Finally, as the most important requirement is concerned, as far as that is concerned, as the data volume grows and the velocity grows, and the directories in the landing zone where that data files are being landed or put in, so we cannot afford to fail over or fail to scale as the directories grow quickly and become large. So basically, in incremental ingestion, we have this is the high level diagram, as you can see what the incremental ingestion requirements are. That is, over here we have some kind of cloud storage. In this case, we have Azure Blob Storage, in which we have a landing zone in which files or whatever objects, audios, videos, or files are being landed in the landing zone. From here, we somehow need to trigger Databricks to basically pull the files and load them into the Databricks environment for further processing and loading into the data warehouse. So, and all the data ingestion requirements which I discussed earlier are applied over here. That is, we only process the latest available files. As the number of files and the size of files grow, we cannot afford to fail, and we must scale with the growth of these landing area files and their velocity. We cannot miss any file, and we need to trigger immediately as well. And we need to use a solution which is replicable across different scenarios. That is, of course, all streaming data analytics solutions, whatever the industry is, requires incremental injection in one form or the other, be it financial services or any other organization. So, in general, there are three patterns available for implementing this incremental injection requirement. In the pattern one, we what we do is that we store or we fetch or extract the ETL metadata. In which what we do is that we basically store the file name or the folder name, which was last processed by our ETL batch. And as you can see, this is ETL batch and not streaming. So what happens is that we create an ETL pipeline which processes micro batches in short intervals. So it doesn't actually create real-time analytics, but near real-time analytics. And it requires storing the metadata of the files already processed somewhere in basically the configuration or in some area, so that whenever the ETL batch process runs, it doesn't fetch the files already loaded, but any file that is placed incrementally, it will load that file into the target area. This is pattern number 2, in which we can use Spark's file streaming feature. So in this feature, we don't need to store any metadata, and the file stream read would basically read the incremental file as and when it comes, and it basically loads that file into the target. Now you might wonder how is that different from autoloader, or why we need autoloader if Spark file streaming is available. So for that, there are multiple reasons. The reason number one is that Spark file streaming is not scalable. Given as the data volume and velocity increases, and as the sizes and numbers of files increase in the landing zone, we need to bypass Spark file streaming and implement custom solutions. So at the moment, Spark file streaming is not scalable. And then finally, we have a do-it-yourself pattern in which we create a complete infrastructure ourselves. In which, for example, we create a blob file trigger. So whenever a file is landed in the zone, a blob file trigger is executed, and it basically triggers a logic app solution which basically picks up incremental files and then triggers an Azure function which uses the Databricks job API to basically load incremental data. So as you can see, this third pattern, it is quite complex and is not repeatable because for any different kind of files or any different kind of requirements, we have to modify this do-it-yourself pattern ourselves so that we can utilize it across different streaming analytics requirements. So wouldn't it be great if we had one solution available which would basically take the best of all these patterns and create a mechanism which is repeatable, immediate, and basically it can be triggered immediately and can be repeatable and doesn't slow down or doesn't stop scaling when the data size increases. So this is basically where autoloader comes in. Finally, guys, thank you for bearing with me for such a long theoretical presentation. Now we'll move on to the case study and demonstration. But before we move on to the case study, let me give you an overview. So this case study will demonstrate how we will use autoloader to calculate stock price portfolio's net present value in real time. In this hypothetical scenario, we simulate a stream of stock prices of three stocks: Apple, Microsoft, and Tesla. The stream consists of CSV files containing transaction ID, stock name, stock price, transaction volume, and transaction timestamp. Once the file is generated, it is loaded into Azure Blob Storage account using the Azure Java SDK. This process is repeated for all the three stocks every 1 minute using a scheduled trigger. That is, every 1 minute, a new transaction CSV file is generated and loaded up the Azure Storage Blob account for each and every stock. As the files are uploaded, on the other end, a Databricks job is running continuously, and this job contains the autoloader feature. The job triggers the autoloader to pull the CSV files, load them into the stocks table, and process them. And of course, since it's streaming analytics, the autoloader must pull incremental CSV files whenever the Databricks job runs. For the processing part, the pipeline aggregates each file to calculate open, low, high, and closing prices of each stock. So it can calculate and present candlestick charts of each and every stock as and when the files are generated and as and when the stock values changes. So in this simulation, following is the portfolio composition. We have 3,750 stocks of Apple long position, Microsoft 4,500 shares, and Tesla 6,750 shares. Finally, the portfolio open, low, high closing prices are calculated based on the above portfolio composition. Now I'd like to invite my colleague Mr. Rahil Fazil to give you the demonstration and presentation of the overall case study. Thank you very much. Then we'll have the question and answer session.
Okay, so as in our previous slides, we have already seen that in our conventional streaming platforms there are certain issues and there are certain challenges, and why streaming is hard. We already covered that in our previous slides. Now let's come to the point in our autoloader, that is what is Databricks Autoloader. Databricks Autoloader is an optimized cloud file source for Apache Spark that loads data continuously and efficiently. We have in our autoloader there are two parts for the autoloader job, that are cloud files reader and cloud notification service. In cloud files, that is handled by the autoloader for the incremental files. But for the cloud notification, that is a optional service that is used for the files which are newly arrived. If we need any notification or we need to change the file name for that new file arrived, we can use that cloud notification service. Okay, so moreover, Autoloader combines our three approaches actually: storing metadata using streaming structured streaming, and the utilizing cloud native components. Our this diagram shows actually how our autoloader takes part in from the storage to the delta lake, how it actually works. Actually this is a high level architecture diagram that okay. Autoloader cloud files reader. As we know already that autoloader supports all types of files that can be JSON, CSV, Parquet files. It can be read through autoloader. So here is our cloud files that are present in our blob storage, and we are seeing that there is an example that we have a JSON file, and to invoke that autoloader we simply use that is cloud files. Whenever we write that cloud files in the format, we will invoke the autoloader. So this is a simple way of invoking our autoloader as using our autoloader service in our Databricks. We simply write down this command. On the same time, we can use this cloud files dot use notification. This command can be used for autoloader use cloud notification service. This command can be used. So this is a simple declaration for the this data frame will treat as a autoloader data frame. For the cloud notification service, as I already explained that in autoloader there are two parts of autoloader, that is a cloud file reading, and there is a cloud file notification service. This is simply whenever our new file arrived, we can use this service for the newly arrived file. That this file is arrived, we can create a topic, we can create, and further we can use this topic, newly file arrived topic, we can use it in our Kafka service or whatever service we can use for this notification. Okay, so let's we start our live demo. Now we will jump into our Databricks platform, and there I will show you how actually this autoloader actually works, and I will show you my complete pipeline. Okay, before going into Databricks, let me show you how we are simulating our stocks data. Actually we have written a Scala code for simulating that stocks data. We are using only three stocks: Apple, Microsoft and Tesla stocks, and our Scala code will run and simulate these three stocks data, and it will send into our container, that is our Azure container. So how we are running this code, our Scala code, we have created a task scheduler which run every minute, and it will send the data that is in the form of CSV. So our container is filling by the CSV files with this task scheduler. This is our container which we have all the CSV files which are coming from our Scala code and generating from the Scala code, and these files are coming in this our Azure container. Okay, now we came into our Databricks environment. So this is my pipeline that I have created. So let me explain you what are the component I have created in our Databricks. First of all, I have created autoloader Databricks delta live table pipeline. This is my code for the delta live table pipeline. Okay, first of all, it will bring all the stocks data into my table. that I have created with the name of stocks table. Secondly, I will create three tables from that stocks table, that is Apple stock table, Microsoft table, and Tesla stocks table. And then in my pipeline I need to create there are the table that is called stocks aggregation. So for that aggregation I need to aggregate the stock prices per file ID. This file actually one time uploaded from our simulation, that is we written in Scala, that is sent to the storage container. We will aggregate that data on the basis of that file. After that we will create a portfolio table, that is aggregation of all these stocks, these three stocks aggregation. Okay, this is my catalog where all the tables are created, and comes here. First of all our stocks table created, then our Apple stock, Microsoft and Tesla tables are created. After that our Apple aggregation table, Microsoft aggregation table and Tesla aggregation tables are created. Finally we create our this portfolio value table. We create this. Let me show you the sample data here, that is our aggregated portfolio price, that we are presenting these prices in our final dashboard, which is here. Okay, so this is a job that I have created to run my that DLT pipeline. Let me run that pipeline now. Okay, so our job is running, that job is created to run our DLT pipeline. So every time our pipeline is running, after 1 minute it will load our incremented data, that is our newly arrived CSV file. It will brings in our delta live table, and it will finally shows in our delta table that we are using in our dashboard. This dashboard is created on the final table, which is our aggregated table, that is our portfolio prices table. So this chart shows our portfolio prices. This is our Apple stocks prices, and this is our Microsoft prices, and this is our Tesla stocks prices. So here you can see our newly data. Whenever it is arrived, it is updated in our candlestick chart. The new data, which is our new file, CSV file, whenever it arrives in our container, it will process through our DLT pipeline, and autoloader it will automatically aggregate it and brings our chart here. Here you can see our latest candlestick, that is from our very latest data comes in our container, and the aggregated value of our stocks price, it is presenting the new candlestick here. So this is end of our practical demo autoloader. In the end, let me quickly explain you what are the lessons we have learned from this autoloader presentation. Databricks platform can be comprehensively used as a single platform for the data and AI solutions. The Databricks AutoLoader service can be used for streaming analytics in a configurable and scalable manner. There are many configuration options available in the AutoLoader, including specifying how merge incremental data into target data store and handling schema evaluation and automatically. Using Autoloader, you don't need to implement any streaming analytics service yourself. You can utilize Autoloader out of the box with some configurations. Thank you for being part of our webinar.